This time what we want to do is have a look at some harder questions on simultaneous equations where we start to use some substitution. So they are harder in this case because we've got different coefficients there. It's not a nice let's label them and we can get a simple substitution. There's a bit of manipulation that needs to go on. So if I take this first equation and manipulate it, I'm going to get here, we're going to go with 5y equals to 1 minus 3x. So I've just subtracted 3x on both sides. But I still want to get y by itself. So y is going to be equal to 1/5 outside of 1 minus 3x. So what I'm going to do now is do this substitution into the second equation. So we're going to get our 4x here. And for y, we're going to have the 3 there. We're going to put in the 1/5 outside of 1 minus 3x equals to 11. Now, notice again, we've got an equation that is all in terms of x. It's not a pretty equation. Yes, there's a bit of work to do to solve x there, but it's solvable because we can get it all in terms of x. So let's do some cleanup and multiply some numbers out. So we're going to get our 3/5, 3 times the 1/5 there. So 3 times 1/5 times 1, that gives us 3/5. We've got minus 3 times the 1/5, so there's the minus 3/5 times minus 3x gives us positive 9x on 5 equals to 11. So we've just expanded that bracket with all the multiplication. So 3 times 1/5 and then multiplied everything in the bracket by the minus 3/5. Now, I can start collecting like terms, but I'd much prefer when I do these ones to get rid of the fractional parts. So we don't really like the fractional parts there. So what I'm going to do is multiply every term by 5. And that means that's going to get rid of the 5 divided by 5 in both of those. But that's going to change that to 20x. That stays at just minus 3. That stays at 9x there. And the 11 would become 55. Because every term got multiplied by 5. Now I've got no denominator. That starts to make it a little bit easier to play with. I can collect my like terms. I get 29x, and I've got minus 3 equals to the 55. And then so I can then add the 3 on both sides. 29x would equal 58, sorry, because we're adding 3 on both sides. And 58 divided by 29 would give an x value that's equal to 2. So there's our value there. Then I take my x is equal to 2. I sub it back into any of these equations. So I've actually chosen the first one. So I say therefore 3 lots of x, which is 2, plus 5y would be equal to 1. So that gives us 6 plus 5y equal to 1. And 5y then would be equal to minus 5. And y must be equal to minus 1. So there's our values for that simultaneous equation. X is equal to 2, y is equal to minus 1. Again, sub it back into any of those. So you can sub it into that equation, any of those, because all those three are the same equation. But even into that one, and we'll solve them simultaneously. Let's have a look at another problem. So this time 4x plus 3y is equal to minus 4. And 3x plus 7y is equal to minus 12.5. Again, a little bit of work. So let's get the first one, and we're going to manipulate it. We're going to take now 4x. Let's get this one in terms of x and solve that way this time. We'd subtract our 3y over there, so minus 4 minus 3y. And then we're going to divide every term by 4 because it's 4x. So that's actually going to give us minus 1. And minus 3/4 y. There's different ways we can write it, but that one's as good as any. So there's our substitution that we're going to use. Because we divided that term by 4, that term by 4, that term by 4. So we get x is equal to minus 1 plus minus 3/4 of y. So from that then, we're going to do our substitution into the second one. So that will give us 3 lots of minus 1 minus 3/4 of y. And then we're going to have plus 7y, and that's equal to minus 12.5. So there's our equation, all in terms of y, which is what we wanted. We wanted to get rid of one of the variables by substituting one for the other. And so just start to expand it. So we get minus 3, and that becomes 9 on 4 lots of y. It's both minus. And 7y minus 12.5. Now again, like I did in the last problem, I don't really like the denominator. So let's multiply everything by 4. So it's going to give us a minus 12. That leaves it with just minus 9y. Now 4 7s are 28, so we get 28y. And 4 times 12 minus 12.5 is going to give us minus 50. I get minus 12 there. Add these two together, it gives me a positive 19y equals to minus 50. So all the fractions went, so that fraction went as well. So hopefully you noticed that. 19y then must be equal to minus 38, because I had 12 on both sides, and minus 12 plus minus 38 would give me minus 50. Divide by 2, and y ends up being minus 2. So there's our value of 2 there. Minus 2 there. So now we're going to want to go back and get our value of x. So let's sub it back in this first equation, and I get 4x plus 3 lots of minus 2, because y was equal to minus 2, and that'll be equal to 4, minus 4. So 4x there equals, minus 6 is equal to minus 4. And so we get 4x must be equal to positive 2. Because minus 2 minus 6 gives us minus 4. And divide by 4 gives us an x value of a half. So there's our values. X is equal to a half, y is equal to minus 2. Sub it into that equation, it should satisfy it. Sub it into that equation, so it should satisfy it. Or even that one, it would work out there that you'll get the both sides being equal. So there we go. There's some harder questions. There's a bit of manipulation to be done, as you can see. There's often fractions involved because we have to get the pronumeral by itself. Like there's our literal equations coming in and manipulating to get those. But there's a lot of work to be done with this type of equation. But sometimes that's what our equations are going to look like. They're not always going to be really simple ones. And again, the higher we go up in mathematics, the harder the equations are going to be.